the next hour, hopefully 45 minutes of me describing kind of what we do every day, which is design sump pump and sewage pump systems. And we represent one lineup of pump, and that's Weil Pump Company. So the company, Associated Heating Sales, has been in the Grand Rapids, Michigan area for 65 years. And this has been the last 5 years in the making as far as going to engineering firms, giving presentations, understanding, what you guys see every day and trying to help you design systems. So hopefully this represents a video that you can go back and replay some areas as you see different scenarios and in designing for jobs. What we do every day is we take the Weil pumps, which is usually a designed, engineered solution, and we couple them with control panels, fiberglass basins, covers. We also sell packaged domestic booster systems. So we're looking at all those today. Our phone number, website should be on the presentation here. Certainly shoot us emails if you need help designing a system. That's about half of what we do every day is help engineers design systems, hand out equipment lists, full submittals, cut sheets so you can see everything that you're writing down when you're designing a job, and hopefully it can be quite helpful. So again, we're in the Michigan area, but feel free to reach out. There's a whole network of Weil Pump agents, and we can help. So we'll first start getting into what Weil Pump has kind of always been and what it represents. It is, known as the All-American Heavyweight. It's out of Cedarburg, Wisconsin, all production. We're going to see their facility in a minute. It's always been a commercial sump pump and sewage pump manufacturer that's known as a heavyweight and an American supply chain. So we do qualify for Buy America. In this current environment where we've seen the threat of tariffs and inflation, our pricing has remained, very steady. So that's been really nice. And this is sort of a design solution. So every Weil pump that leaves the factory is wet tested, and the impeller is sort of custom trimmed for the duty point that you write down. So we're into commercial buildings, anything above residential. A lot of our jobs are schools, hospitals, production facilities, apartment buildings, items like that. Weil has really stuck with the heavyweight design. A lot of our pumps are double the weight of the competitor pump, and they've stuck with the air-filled motor chamber. So we'll look at that. Their claim to fame is that 0.25% of the items that get sent out from their factory end up back on manufacturer's defect. And we've certainly seen that throughout the years. We have not had many issues. Really nice when the pumps show up on site and they work as designed. And if there's ever any issues, we know, okay, maybe it's how we hook them up. The power leads are switched, the pump's running backwards. There's some simple fixes compared to headed back to the manufacturing facility for a whole redo. So it's been really nice to represent, Weil Pump. Here's their headquarters in Cedarburg, Wisconsin. Everything's under one roof, the production, the R&D, the administrative, really nice facility. It's new as of 2022. They have a whole Olympic-sized swimming pool underground that they're building right now to test some really large pumps or kind of increase their capacity to test pumps as they go out. Usually in these presentations, I'm sort of asking what you see the most. So we'll just kind of cover all these items today. The first thing I always like to do is go backwards in time a little bit and show you the vertical pumps that were very common. They're still useful today in some scenarios, and I would say it's heat or corrosive environments would be the best kind of environment that you'd want to put a vertical pump into. The vertical pumps, they put the motor outside the pit. My cursor here, you'll see the motor's outside the pit. It's in a mechanical room. It has a motor that's coupled to a shaft that runs down to the impeller and pushes the fluid out the discharge pipe. So again, these were very common. They still last a long time. They're a heavy duty pump, and they do really well when we can get the motor out of the pit so the motor doesn't burn up under heat or corrosive environments. We can make the legs and the discharge pipe stainless steel. We can make the graphite bearings here where you don't need lubrication in a high heat environment where the lubrication would kind of melt away or go away quickly. You can use graphite bearings and a stainless steel impeller. So these are still quite useful if you have a harsh condition present and that you need a vertical pump. I would say they also last quite a bit longer, and motor shops can rebuild them at least once in their lifetime. So a new shaft, new bearings, and the pump is back, kind of running because the motor is usually quite good for a long time. Some advantages there that we just described would be, hey, it's a long-lasting pump and it does really well with those conditions that are a little harsher. Some disadvantages, these vertical pumps require some maintenance. So there's a lubrication line. So weekly sort of lubrication would be probably recommended there. And then you can't put them into deeper pits. As you put them into a deep fiberglass basin or pit, these vertical pumps get longer and they'll burn up more quickly as that long single piece shaft wears into those bearings more rapidly. So really pretty neat, something that you might see on your remodels or your renovations. You might see these in place. Here's one that's pulled out of the pit. Every single one of these is made to a length that's within 3 or 4 inches of the bottom of the pit. Here they are installed. Here's a wild nameplate with the SO number on it. If you ever run into this, this is a great number to give us. We have all the historical records there on those. So these vertical pumps. Another nice part is if you see another brand that's obsolete, they don't make them anymore. Weil Pump is one of the pump companies that still makes these vertical pumps. It's very easy to kind of retrofit onto these heavy duty covers where there's a standard opening size, typically 18 inches across. 95% of what we sell are submersible sump pumps now. So they've gotten really good. They last a little bit longer than they used to. I think this has become sort of more common. They are very cost effective in deep pits. So you can place them on a rail system, which we'll look at later. We don't have to build a pump that's longer than a submersible pump. There's no periodic maintenance required. Really nice for buildings that don't have a staff that's got weekly checklists, because again, there's no grease or lubrication points. And they're ideal for outdoor covers where they need to be flush, tamper-proof. They're under the cover. They're hidden quite well. Or inside when you need to go outside the cover or outside the basin with your discharge and your vent and your electrical. So we'll look at all that. Here's a wild cutaway of a double seal pump. So this is a wild pump. Starting from the bottom, you have the impeller, the case where the fluid enters the pump. Then you have the seal chamber next. And why this is a double seal pump is you have two mechanical seals, one on either side of the seal chamber. You have biodegradable oil here. This makes this larger pump longer lasting. So the seal chamber will push away water or debris that's getting into the pump as this seal fails. We'll talk about sensors later that are placed within the pump that can tell maintenance personnel that this pump is starting to leak or the seals are starting to break down. But the big difference on what you might see between a Weil pump and more of a budget on the shelf residential versus commercial would be sort of this heavy duty castings with air filled motor chamber. You'll see the competitors in the space where it's commercial, even municipal, stick with air-filled motor chambers. The idea that this air-filled motor chamber, if it's asked to run continuously, would cool down with the cooling fins a little more rapidly than a hot bath of oil. You see a lot of pumps with oil-filled motor chambers that are at just a different price point and a different application. So Weil stuck with this design. They have fully enclosed bearings as opposed to open bearings where you're relying on that oil to lubricate the bearings. Oil may dissipate over time and leave those open, whereas Weil has kind of stuck with these fully enclosed bearings. So here's a cutaway. Weil also sells single seal pumps. So at about 2 horsepower or greater, you have double seal pump options. It makes sense. You're paying a larger upfront cost. You want this pump to last longer, you get the double seal pump, but the lower price point becomes the single seal pumps, which you see here. We have one mechanical seal and we've lost that seal chamber. So these typically head into elevator pump systems or small duty point applications that don't run very often. 2 horsepower or less, 1.25 all the way up to about 3 inch on the single seal options. If you're in a scenario where you need an in-stock pump, Weil has some in-stock pumps as well. They might go into an elevator just fine. So let us know. Elevators are typically, if you're doing 50 gallons a minute, 1/2 horsepower pumps, might work quite well. We'll get into a little bit about the differences between a sump pump, so just groundwater, versus applications where you're pumping sewage. So you have sewage systems. The big difference is the case and the impeller. On the left, you see the groundwater pump where the impeller is in tight tolerance to the case, and you're typically only moving 1/2 inch solids through this pump. So this is groundwater. On the right, you have a sewage pump where you have the impeller can pass 2-inch solids through it. That's how we define our sewage pumps. They can pass 2-inch solid spheres through the pump, and that's going to make it a sewage pump. Some other options that you see on the market, starting with the bottom one actually is a slicer. We really like these. No big issues here because they're typically paired with a double seal pump, high horsepower, high flow, these slicers do quite well. The grinders do okay, although I will say an undersized grinder is the one that we get the most calls about. It's clogging on items, it wraps things up. The idea here is that this grinder apparatus sits at the opening of the pump or the entry of the pump and grinds up sewage to a more pumpable size. This might be nice in sort of a residential application where you have complete control over what's being flushed and you're never going to flush a wipe or a hygiene product that shouldn't be flushed. But into the commercial application, this is most often what we see. The smaller grinder pumps will wrap up on the hygiene products and really burn up pumps quickly as soon as it's there. I mean, it sort of relies on momentum as well. So when you can see if something's wrapped in there, the pump tries to turn on, nothing spins, the motor heats up and burns up rather quickly. So this is what we found in our experience. So if you called our company, asked for a design, we would look to get you into this standard sewage pump. It'd really be our go-to if it was a typical application. There's one more design that's even better at not clogging items. And I guess if you said, hey, I have a hospital system, a medical facility, a high school was last year where they would it was a high school football stadium. They would flush every item of contraband they brought to the game. So shooter bottles, vape pens, things like that. They were constantly clogging up these grinder style pumps. And that would be the Weil mover pump is kind of your third option. Everyone at the medical facilities that have moved to these said, hey, this is great. We don't have to pull these anymore. They do really well. What we're doing is we're adding a low profile impeller to a larger sewage case, and we're pumping via a sort of fluid dynamics or vortex sort of fluid here. This is a less efficient process. So every Weil mover pump needs to be an additional horsepower at least when it comes to your standard sewage pump. So you might go from 2 to 3 horsepower or 3 to 5 horsepower with the mover pump. But once these are in place, we've really had no issues. People have loved these. We've got a couple of hospital systems across the state that use these exclusively and have been really happy. So if you are running into clogging issues, these wipes that everyone's using, different applications where they have no control over what's being flushed, the Weil mover pump has been great. Definitely pumps, things along the line to the larger pipe sizes, the municipal systems, and getting them out of your end user that's at the commercial level system and not wrapping up a pump and burning up a pump has worked quite well. A few slides on what you could add to a pump that would make it sort of last longer in a heat environment, a corrosive environment. Let's first talk about sensors. We mentioned these earlier. In an expensive double seal pump, you may want to add the sensor package from Weil. It'll get you two sensors in the pump. The top one here detects water in the seal chamber or the motor shell and will alarm the panel. At that point, maintenance personnel could pull the pump, maybe take it to a motor shop and have it rebuilt, resealed with new O-rings, new seals, and you would have saved an expensive pump. This would be the idea, is saving a really expensive double seal pump before it burns up. The bottom is a temperature limiter. It's going to be in the windings of the pump, and it will turn the pump off if it becomes too hot. If it becomes too hot, it'll allow it to cool down and it'll automatically reset it. But in the meantime, it'll light up a light or sound an alarm in the panel, and the maintenance personnel will understand, hey, something's going on with my system. We get this question about a high temperature system often. So anything above 150 degrees, you may want to start to think about, high temperature package from Weil Pump. If you want the highest rated pump in the submersible pump category, an all stainless steel pump would be the best. Unfortunately, all stainless steel pumps are 4 times the cost of cast iron pump. And we'll look at that in a second as well. But there is a go-between option. Let's say you're below 180 and you want a submersible pump system. Weil in their high temperature pump package will put a derated motor that operates at a lower temperature, Viton seals instead of nitrile that hold up well, high temperature oil in that seal chamber, and you'll have a high temperature pump in the submersible category. Oftentimes a bronze impeller too. If you are close to boiling at 200 degrees and you have an indoor pit where it's shallower, you don't have a deep basin, a vertical system, like we mentioned before, it could work really well. So some different options here. Corrosion. If you have fluid present in your pit that's corrosive, you have some options. I guess when I look at what's happened over the last 10 years as far as corrosion-proof pumps or resistant pumps, there's two different categories of consumers or customers in the end here. The all stainless steel pump, which you see over here, we sell a few a year. They're very expensive. They're 4 times the cost, as we mentioned. They work really well. They're rated up to that 200 degrees. They'll be in there a long time. And to give you an idea, because they're so costly, the customers that have bought these are like last few years, Coca-Cola, Ford, Amway, some really big names. And they have production facilities that just can't be down. So they don't have equipment that isn't long lasting and isn't redundant. And so this would be a great choice for those sorts of customers. We do have a go-between option. The go-between option here, we'll call it the hybrid, is sort of our, second step up from just regular old cast iron. And this represents an increase in price, maybe times two. So this is a really good option for someone that, isn't these large names. Last year it was a milk producer. Milk producer was going to put old or spoiled milk in a pit. It's going to become quite acidic over time, and the pump was going to sit in there. So what we'll do in this hybrid option is we'll make the case and impeller where the fluid touches this pump or goes through this pump. We'll make that all stainless steel. We'll take a cast iron motor shell and we'll paint it with a chemical resistant epoxy paint and put a premium cable on the pump. And this will last quite a ways. This has been very popular in that different price category. The last condition that we see often is explosion-proof pumps. So most often in our area, it's a bus or a vehicle maintenance, so heavy-duty vehicle maintenance garage, and they're draining all the fluids, ending up in a floor drain, ending up in a sump pump pit that needs to be pumped out to the main. And those fluids that are present are combustible. So any sort of spark may cause a fire or explosion within the pit. An explosion-proof pump is built in a way that no spark will leave the pump. Right? So your UL listed for hazardous environments. It includes those sensors that we talked about to let you know when something's going wrong with the pump. And there's flame arrestor pathways and special sort of build here to not allow a spark to leave the pump. It's also coupled with intrinsically safe controls, so low voltage, intrinsically safe relays within the panel to floats that run on low voltage. Typically, there's gold-plated contacts within those floats to allow for controls to operate, and again, to not allow for any sort of sparking to occur outside the floats. Okay, getting into how we typically draw up our different pits, I'd say one of the more common things that you see is an elevator pit. So you're in an elevator hoistway. The fire code says you need a sump pump in the bottom of every hoistway within a pit to pump any fluid that accumulates in the elevator pit out. The fire code says you need a 50-gallon per minute pump for every elevator car. So it's typically housed within a concrete pit or a fiberglass basin that's 24 inches deep by 24 inches wide. I will say, your question may be, when do I do a basin versus a concrete pit? Can I just allow the concrete contractor to pour that pit? If you're in a standard one-car elevator, great. By the time you're into 2 cars where it's 100 gallons a minute, you may consider doing a fiberglass basin, because the company, our company, for example, that sells everything as a package will understand if that needs to be larger. If you're into 100 gallons a minute, sometimes your pump is taller than 24 inches. So you have a larger pump, you'll need a deeper basin. This basin would have a perforated cover to allow all the fluid through it. If it's a concrete pit, there's typically some grading over top. But that would be, how I would decide whether I say it's a fiberglass basin or a concrete pit. They're typically paired with a control panel. Sometimes we see drawings where it's a single float that's actuated up and down. That really eliminates the chance that you have a way to really test the pump, to make sure it's still working. It eliminates alarms. So a control panel would be the way to go. So you get an alarm, you get the ability to test the pump. You also have a building management system. Dry contact hookup is typical for the sump pump category. So you get dry contacts within the panel to hook to your building management system. It can tell you if this pump's turning on. So a control panel, we kind of view that as a must. The one wrinkle as far as how to design for a traction elevator versus a hydraulic elevator. Traction elevator is more common nowadays, becoming kind of the go-to. I would say a standard sump pump and panel is you have no worries there. A hydraulic elevator, it has hydraulic fluid present, and the plumbing code says that we cannot pump that hydraulic fluid or oil, hydrocarbon out into the environment. So you need a way to leave that in the pit and still continue to pump or never shut down this pump in case fluid or water is coming in to fight fires. It's a fire code issue. So 99% of what we sell nowadays is an oil smart control panel. And we'll look at how it's set up. I even have a video for you guys, but we've done away with floats and we have sort of this deck of cards looking item that gets attached to the discharge pipe. And it sees that once water submerges both probes here, the pump turns on, but it won't turn on if the oil touches these probes. So you have a layer of oil on top of the water that continues to remain within the pit and never gets pumped out. So we'll look at that in a second. Historically, this might have looked a little different, but I know the plumbing code has changed over the last 10 years. And this is nearly 100% of what we sell is this simple oil smart control panel. The oil sits on top of the water and never gets pumped out because the pump draws from the bottom column of water. So you can see how the water would rise, hit this probe and turn on. And if there was any oil present, it would continue to float on the top. This also comes with a high water alarm that tells the panel if there's water or oil present. So you'll alarm the maintenance personnel that there is oil present. It's a key part of, what the code says as well. So let's look at that video real quick.
All systems include the Oil Smart switch and Liquid Smart alarm technology. The Oil Smart switch is an IP68 rated reliable and durable oil-water switch. It includes two sensors. When water comes in contact with the on sensor, the pump will turn on and remains on until the water clears the off sensor. During normal operation, water will make contact with the on sensor and pump the water just below the off sensor. Due to the low dielectric value of oil, the pump will not activate when oil comes in contact with the on sensor. However, if the pump controller detects a field of water under the oil, the pump will activate and pump the water out from under the oil, stopping the pumping process prior to pumping any oil. Under conditions where there is a large layer of oil and the pump does not start,
So you kind of understand the two different cartridges, we'll call them, operate, the operation of the pump and then the alarm. And it'll always leave the oil in and maintenance can come back someday and pull out the oil. They'll get an alarm that something's going on and they'll have to dispose of that oil. Historically, there was oil separators that were in line. There was also a system where you had two solenoids where you would push the oil into a containment tank, and we haven't seen that for a number of years. And you can see that. Please go check the plumbing code wherever you are. Make sure this all works. But this is almost all of what we sell nowadays, so that's what we can speak to. I do have a chart if you are looking to specify a Weil pump for your elevator system, and it asks you your duty point. So how many feet ahead are you pumping against and how many gallons per minute? Keeping in mind this is per elevator car, 50. So these are the most common model numbers that are used for a Weil pump at that system. We're going to talk about the drawings that you'll see for typically duplex sump pumps or duplex sewage pumps. When I say typically duplex, I mean that most of our systems are duplex because there's redundancy in these commercial buildings that allows the commercial building to continue to operate while one pump is down. So for sewage or groundwater, you have a gallon per minute flow that you've designed for. Each pump in these systems can do that full flow. So you could technically operate on one pump while the other pump's being fixed or ordered, a new pump's being ordered. And that's most typically what we see in commercial buildings because we just don't want to be down. We don't want to shut all the, fixtures down, things like that. Duplex pump systems have 4 position points for their controls. Typically they're floats. We'll talk about the options here. But the off float down here turns the pumps off. The next float is the lead, or the on float turns the pump on. The next float is the lag, turns the second pump on. And the high water alarm is the next float. Our control panels are alternating. So each time a cycle happens, a different lead pump turns on. So they're alternating control panels. Looking at controls real quick, the most common is our mechanical floats. They're strapped to either a pipe, so they're either tethered to a pipe or suspended from the top of the pit. If your pit's really deep, suspended, it's usually the way to go because a long length of pipe is hard to get. So 15-foot deep pit, a 15-foot pipe is rather hard to install into this cover, so suspended becomes the option there. But anything standard, floor mounted, shallower basin, below 6 feet, sort of the tethered pipe mounted floats. The next option, which is a great option and should be probably coupled with the vertical pumps if you have a high heat or corrosive environment, because it lasts so long and it's really heavy duty, is this pedestal mounted float switch. What I would say is, you see this rod that's connected to a stainless steel ball. The stainless steel ball floats up and down and actuates the switch, which is above the cover. Nice part about that is the switch and the electronics are all above the fluid environment that's hot or corrosive or just submerged, and the switch lasts forever. And the stainless steel float ball lasts forever too. So this is a long-lasting way to do this. Downsides, obviously, is you have to be in a mechanical room because this is sitting on the cover represents a tripping hazard, and you got to have room for this in a mechanical room. But these would typically be coupled with our vertical pumps or a high heat system. Maybe you have submersibles, and this would be the best way to do controls. There's 4 positions for this switch above, and there's stoppers that actuate that. So it's a nice way to do it. Your last option is a level transducer, and it's typically paired in a system that should have redundancy in its controls, because you can see how these transducer panels that are typically variable frequency drives have backup floats. So you have 2 ways to do this. So if this transducer fails, you have backup float operation, and you have an alarm, and you can replace the transducer or see what's going on. The variable frequency drives are typically used in sump or sewage pumps that are high horsepower, so soft starts and soft stops. Say that 10 times. For example, that Coca-Cola job where you had triplex stainless steel pumps. You needed redundancy everywhere because in no way do they need to have their production line go down at all. So level transducer is really nice for that. Soft starts, soft stops, and then redundancy. So this is a nice way to do that. This would be your sort of, you need as much redundancy and reliability as you can get. Okay. The only other thing I'd like to point out is how these pumps sit. So this is going to be a floor mounted pump with a vertical discharge that's sort of installed on the pump. So when you go to remove this pump, you're removing the pump with a chain up through the pump opening here, and you have a discharge pipe that's quite long that's attached. So this gets us into when we need a rail system. If this pit is deep and we're indoors, so let's say it's 10 or 12 foot deep and we have 8-foot ceilings, removing that pump with this large discharge pipe will be quite difficult. So your maintenance personnel is going to thank you if you go ahead and utilize a rail system. Just sort of an example here, if that pit was 10 foot deep below, look how, undoing this plumbing, I'll say about 14 foot, something like that, a discharge pipe to get up and out of there becomes sort of impossible unless you use a rail system. So this is what a rail system looks like on a drawing. This is what it looks like in real life. It's a little easier here to see. So what the rail system does is it establishes a permanently installed floor elbow, discharge pipe, and guide rails for this pump to go up and down on to be installed. The pump sits on this floor elbow with the cleat, and the cleat and pump are the only thing that run up and down and out of the pit. So everything else is permanently installed. So it eliminates that large length of pipe that is going to be impossible to get out. This is also a must for a system where you see on the left here where you need a flush cover. So you're heading out the side of the basin with the discharge, the vent, the electrical, and you need a flush cover. Nothing's coming up through the cover. You're going to need a rail system. Otherwise, they have to undo quite a bit of plumbing just to get a pump out. So let's look at a video here of this rail system. It'll give you an even better look at how it works.
Weil's quick removal systems allow for the installation and removal of the pumps without the need to enter the basin. To install the pumps, simply slide them down the guide rails and they will automatically mount to the quick removal elbows at the bottom of the basin. Likewise, removing the pumps for maintenance or service is as simple as lifting them out of the pit. Weil's quick removal systems are available for 2-inch, 3-inch, 4-inch, and 6-inch pumps.
Yeah, so nice look down at how that all looks installed. Becomes really important to have a large cover up top so you can clear this opening. So a lot of our minimum basin sizes, minimum cover sizes, minimum openings in the cover get a little bit bigger with these rail systems because now you have a pump with a sliding bracket that needs to clear out through the cover. The other nice item that you saw in that video, let me start this, is the valve assembly. So here's your drawing. Let's go back one. This is the drawing of the rail system in a deep pit indoors. You're still running the discharge pipe through the cover and the vent. This is the more common scenario where you have either a deep pit or an outdoor pit or an area where you need a flush cover. This could be vehicle rated cover, vehicle rated hatch, concrete over it, or it could just be your standard cover in a indoor area where people are going to walk over it. You're not in that mechanical room where you can get away with piping coming up through there. So this is what that drawing looks like. And the item that you saw, so the last item to talk about, is that valve assembly. This is the 2616 valve assembly from Weil. And what this does is it provides both the check and isolation valve requirement for both pumps. It's compact. It sits in line with the removal system that you see here. So the contractors love when we provide it because it saves them so much time. In lieu of this, they would have to plumb their own check and isolation valve for each line, and it might get shoved down the pit where it's hard to reach. This provides something that's right near the top of the pit, and it satisfies both those requirements. This is State of Michigan, Hall of Justice. They have a truck dock in the back where they drain a lot of groundwater because it's below grade from the surrounding areas. This is an example of where this valve assembly was really valuable to the maintenance staff. And what we did is, these are 15 horsepower, I believe, 6-inch pumps. And the 6-inch valve assembly went in really nicely and saved us from having a valve box next door. I mean, this is all existing and this is sort of a retrofit. So this worked really well for that. And it's right near the top. The maintenance personnel was, when we went out to do the startup, was describing how awful the old system was to work on. You had the valves and everything down below within the pit. So this represented a big upgrade for them. So this is an example of kind of how that ends up looking. It's a deep pit, maybe 15 feet, and then they put a brand new heavy duty cover on top. They used to have semis that would drive over their cover and break it and bend it. So a couple bollards in the way now. So they'll know they're on the wrong track if they're backing up into that. Here's an example. I'm just giving you some real world kind of looks at how these all end up looking. This is below grade in an existing basement. They finished out the basement. They needed a sump system. They needed to cut the basin into 3 pieces because they had an existing stairwell. So understanding kind of the opening for the stairwell, and our basin company provides a 3-piece basin that gets reinstalled in the basement or reconstructed in the basement and then put into the ground. Here's your valve assembly tucked right here where it's easy to get to. Everything's below the cover and everything fits. I would say if the plumber had to plumb their own check and isolation valve here, you may have it way out of the way, hard to get to. It may not fit. Things would be an issue. You'd have a less reliable or easy to work on system, I would say. So, okay, into pump sizing. This is going to be the first thing you want to let us know when you get a hold of us to design a pump, and that's your duty point. First part of your duty point is how much flow do you want the pump to do? In sewage pumps, that's based on the number of fixtures that are feeding into the pit. I have a nice worksheet, but you get a fixture unit count. And again, each pump is doing the full flow. For groundwater, if you have a basement that has peripheral drains and you know the square footage, maybe the soil conditions, pretty straightforward for us. If you're outdoors draining from a large area like we saw at the Hall of Justice, a little tougher. A drainage study, maybe a civil engineering crew could help you figure out the flow, but that was a little tougher for us. So those are the two, kind of starting points, is how much flow you need. And then the second consideration is how much feet of head you're pumping against. In pumps, it's feet. So most of the feet of head you're pumping against is the total vertical rise in your system. So where the pump's located up to the highest point in the pump line, that's your vertical component. You do add a horizontal component. It's very little. It's very little if you're in an appropriate size pipe, is what I should say. So when you go from 2-inch to 3-inch, the 3-inch line really does not have a lot of friction or horizontal, head that we're adding to it. If you do 2-inch, it could be quite a bit. So let's just kind of look at an example to kind of illustrate my point there. It was a little confusing, but the vertical, we're going to add then the horizontal. So we know the vertical in this case was 18 feet. So from the pump at the bottom of the pit all the way to our highest pumped point, 18 feet. We're running 200 feet to our main. And if we ran 2-inch pipe, because we have 2-inch pumps maybe in this case, each 100 foot of run is going to add 5 feet of head. So we're actually adding 10 feet of head to the system if we have 2-inch pipe. If you simply ran the system in 3-inch pipe, 4-inch pipe, you have very little friction. For each 100 feet there, you're going to add 0.6. So you're really only adding 1.2 on the horizontal. You add some fixtures here, so elbows, check valves, isolation valves, adds very little. Most of your head is going to be that vertical component. Add a couple feet of head for the horizontal, but look out for this 2-inch run. This is going to add quite a bit. This is at 50 gallons a minute. So as you go up in gallons per minute, you may see even more head being added. Okay, last factor for the sump pump system. Hey, I've got my duty point. I'd really like to know what size basin. This is crucial for the engineers when they're looking at a footprint of a mechanical room. I don't have much room. I got 3 feet here. What size is the cover? To give any idea, 2-inch system, typically our minimum for a duplex for a 2-inch system is going to be somewhere around 3 feet. For a 3 or 4-inch system, you're at 4 feet, 4.5 feet. So it becomes important to sort of pre-plan everything out here. The first consideration is just what we're talking about. I know what pumps I want to use. Does everything fit? So you have a minimum diameter. And you can see how we're right up against it sometimes on our designs, which is fine. And then here's a room that has no real room for more diameter either. So a couple considerations there on your side and my side of it. The next two are leading us to how much runtime does a pump have when it turns on for its cycle. So let's just look at this. I'm going to ask you where your lowest inlet comes in because I'm going to start my float tree right after that inlet, below that inlet, I should say, so we don't get fluid backing up into the inlet. Every 3 inches, we put a new float, and we want the largest distance between floats, between the off float and the lead or on float. So this pump operates at a longer cycle or its longest cycle it can. We're often limited with basin depth. We don't have unlimited basin depth is what I'm trying to say. So we can't put in a 15-foot basin and all that. We're typically at around 8 or 9 feet, on some of these systems. So we need to understand, how much depth so that my pump runs for at least a minute and a half. That's going to be a short cycle if it runs for 30 seconds or a minute and turns on very often throughout the hour. If we can get the pump to run for a minute and a half or 2 minutes, Weil says, hey, that's no longer short cycling the pump, and that's an appropriate runtime. So just to do some easy math, every Weil cut sheet has how many gallons are in each foot of a certain diameter basin. In this case, I have a pump doing 100 gallons a minute. I'm in a 4-foot wide basin. So I've made this really easy. It's about 100 gallons per foot. So I need a 1.5 feet of distance between the on and the off flow. Your calculation may be a little different, not as perfect, but I avoid public math this way when I do the presentation. So I have a 1.5 feet. If I had 2 feet here, I'd be even more excited. That way, if the inlet came in a little lower than expected in the field, you have a little wiggle room. These pumps don't short cycle and they don't burn out early. So you provide a lot of wear on a pump if you short cycle it. Hey, we're done with sump pumps and sewage pumps. I'd like to quickly talk about another product that Weil has been selling, the domestic water booster system. So these are drinking water certified. At a certain point in a building, when they receive city water and you have to go up a number of stories, you need to provide that furthest fixture with enough PSI. So this is a booster system, typically in the basement where they're receiving municipal water, that's boosting the pressure throughout the building to achieve a certain PSI to feed that final fixture, is what we're saying. Same thing that we talked about with sump and sewage pumps. These booster systems are well made. And so they have some design features that are, high quality. There's a couple different lineups having to do with the difference in motors. And we'll look at those 2 lineups. But in general, they're built kind of the same. And I'm going to start by kind of showing you how things are built. On the lower, which is a nice feature, you have a skid, but you have anti-vibration feet that are fully adjustable. So you'll see some in the market, these booster systems that are just on a metal skid. You worry about noise, vibration, moving things around, things moving around over time, or putting pressure on your piping. As you move up, the check valve here is full ANSI connection compared to some threaded or proprietary connection. Really nice to work on in the future, widely available. The full lug butterfly isolation valves here you can work on one side of the system without taking this apart. You'll see some wafer style valves on the market where everything will fall apart when you start to work on it. So these are really nice. And they have full detents here, so you can set these to different settings to provide a little bit more head pressure, and it'll stay in place. It won't, you know, work its way over time. The connections are full ANSI connections with end plates. So as you're out on site, you can move discharge and suction to one side versus the other. And then the really nice feature here also is you have redundant pressure gauges on both the suction and the discharge. So you have your digital, which is what your panel's running on, and you have your analog. So the nice part about this is if you have a failure of a transducer, which does happen over time, you can quickly look and compare the numbers that you see on the panel to the analog gauge, and you'll be able to understand if that's a quick fix, it's an easy fix. Great. What I'm showing you here is the Weil 5300 line. This is going to be smaller duty points as far as flow and pressure. You've got a horizontal pump here with a single impeller. Weil also makes a 5100 series. It has vertical motors with multiple impellers. So this 5100 series can handle higher pressures, higher flows. You'll see, this competes with some of the other brands on the market as well. So the idea here is that this panel, which is made at Weil Pump as well, has variable frequency drives to slowly turn a pump on or off to meet the demand at the building. So we're going to keep the discharge pressure of the discharge manifold the same, no matter what the demand is from the building. Designing these, you have a certain amount of flow that you need, and that can be found through the fixture count that you're supplying in the building. And Hunter's curves will tell you kind of what to design for. Usually there's an 80-20 rule here with the boosters. So 80% of the time, these boosters live at 20% of their demand. Vice versa, 20% of the time, they might see 80% of their demand. So when we talk about redundancy and building some redundancy into this flow, our duplex systems, each pump could handle 80% of the flow. And that's how we do redundancy. And so you can definitely get by if one of these pumps is down. If you have a triplex system, you're going to see one pump be 50% of the flow. So you'll have 50, 50, 50. So two pumps fully on would be 100% of the flow. And then you have that backup pump essentially does another 50%. So that's a good way to do a triplex system. These are kind of what the numbers are as far as designing here. The biggest thing for the engineer to figure out is how much PSI loss along the way to that furthest fixture is going to happen. And again, that's a component of that vertical as well as the friction throughout the piping, horizontally or at the length and the fittings. And then what's my PSI that I need at the furthest fixture? There's typically flow reports from the city that tell you how much you're getting. And then we'll go ahead and determine the boost pressure. So just some numbers here that make sense, because when you go to schedule this, it'd be really nice to list out everything. That way it's very clear. This is our example that we helped with in Holland, Michigan. It's a hotel. We need 150 gallons a minute with our 500 fixture unit hotel. We know we're getting 25 PSI from the city on the suction manifold. Again, we're monitoring that here. We're also monitoring the discharge pressure. If we get total lack of pressure here, we have an alarm. Or we're pumping against, no head at all, we're getting an alarm. We have a lot of built-in alarms in these systems, which are pretty standard across the industry. But we know in that final run, or that critical path, we'll call it, we're going to lose 35 PSI. And we'd love for that final fixture to have 40 PSI. So our discharge manifold needs to be at 75 PSI at all times. And so the difference here between the discharge and the suction is 50. So we're going to call that boost pressure. Listing all these numbers in a schedule would be ideal. It helps us kind of figure things out. Example of how that ended up looking here. And another one at a early childhood center. So a couple nice, kind of installs here. And then you get the horizontal pumps for the 5300 model. What we've, come to understand there is it's a heavy duty build. Same thing we would expect. We've got really quick lead times compared to some of the other producers because everything, again, Buy America certified. So we're how the supply chain in the United States allows things to be built and sent out rather quickly. Also, a nice part is everything from the panel to the pumps, everything's produced over at Weil. And so troubleshooting's all in one spot as well. So it's been really nice. Okay. Um, End of our presentation. Feel free to call us or email us anytime. We're really quite responsive. You see a picture here on the right. That's Al, my father. He owned the company for 10 years, and now I own the company. This is 2025 when you're watching this. In 24, we had a huge growth and we're able to reach out. Got an award from Weil on our growth. So it's definitely a positive future that we're looking at. And it's been a lot of fun. And part of it's been reaching out to engineers. So feel free to reach out and we will help with designs as needed. So thank you.